Hello, I'm David March from Florida State University, and I'm going to talk about some work that I've been doing on the automaticity of threat processing. Okay, rapid detection and avoidance of imminent danger is a crucial responsibility of the mind, and humans ostensibly inherited a neural architecture that preferentially processes and responds to immediate survival threats. This is known as threat superiority. And threat superiority manifests as earlier detection and faster and stronger responses to threatening than non-threatening stimuli. And a lot of research utilizing supraliminal presentations suggests that threatening stimuli are more quickly detected and evoke stronger skin conductance and startle eye blink responses, and also evoke earlier and stronger neural responses in the amygdala and the cortices. But two problems complicate attributing those effects to an acute threat sensitivity. The one problem, which has been addressed but remains relevant, is that threatening stimuli are also negative. And without distinguishing threatening from negative stimuli, most studies cannot differentiate sensitivity to threat versus a sensitivity to negativity. In my prior work, I addressed this problem by comparing responses to stimuli that were threatening, non-threatening, negative, what I'm just going to call negative, positive, and neutral. And relative to other stimuli, threatening stimuli were detected more quickly, more frequent targets of initial eye gaze, and initiated stronger startle eye blinks. So it seems like threat stimuli are at least processed uniquely, but are they processed preferentially? This question remains because supraliminal presentations do not distinguish whether faster and stronger startle responses or other responses to threats are due to threat superiority effects or the opposing effects of attention and conscious processes evoked by non-threatening stimuli. For example, faster detection of threats in visual search tests might reflect slower disengagement from non-threatening stimuli, and stronger startle eye blinks to threat might reflect greater attentional capture, which inhibits blinking, of non-threatening stimuli. This problem could be rectified with subliminal presentations of stimuli, which prevents conscious perception and thereby eliminates the competing effects of conscious processing and isolating the hypothesized effect of threat superiority. And while there are indeed subliminal studies consistent with threat superiority in terms of stronger skin conductance and startle eye blink, unfortunately, like the supraliminal work before mine, none of these studies distinguish responses to threatening stimuli from non-threatening negative stimuli. And consequently, those studies do not clarify whether the effects were unique to threat per se or a more general response to negativity. The current work addresses both problems to test whether the mind is uniquely sensitive to survival threats. In two pilot studies, I ensured the subliminal nature of the stimuli. And then three within subject studies subliminally presented threatening, negative, positive, and neutral stimuli and assessed skin conductance, startle eye blink, and evaluative inference. If the mind is uniquely sensitive to threat as a functional adaptation for survival, then reflexive responses like skin conductance and startle eye blink should be stronger to subliminally presented threats than non-threatening stimuli, and such responses should influence downstream judgments. So this was the paradigm basically for each study. Each trial in study 1 began with the fixation dot, and in studies 2 and 3 began with the pre-mask. So we have this centrally located fixation or pre-mask mosaic that was replaced by a 21 millisecond image that was backward masked by a 3 to 5,000 millisecond mosaic. And in studies 1 and 2 ended with a 4,000 millisecond blank screen, or in study 3, a screen that presented a 1 through 5 scale where 1 equals negative and 5 equals positive. And up here on the top right, you can just see these are some examples of the stimuli from each of the categories: neutral, positive, negative, and threatening. Okay. So here are results from study 1. What we can see is larger skin conductance responses relative to the undifferentiated responses to negative, neutral, and positive stimuli. So threat stimuli uniquely affect autonomic responses. In study 2, we can see larger startle eye blink responses relative to the undifferentiated responses to negative, neutral, and positive. So threatening stimuli uniquely prepare the body to respond. And in study 3, we see more negative valence ratings relative to the undifferentiated responses to negative, neutral, and positive stimuli. So people are able to feel the threatening stimuli. And so in all 3 studies, threat differed from the other 3, and there was no systematic variability among the latter 3 categories. So to summarize, the empirical literature on threat sensitivity has suffered 2 problems: distinguishing threatening stimuli from negative stimuli, and differentiating whether responses are sped and strengthened by threat sensitivity or delayed and diminished by conscious attention to non-threatening stimuli. I addressed both problems by comparing responses to empirically validated sets of threatening, negative, positive, and neutral stimuli, and isolating threat sensitivity from the opposing effect of conscious attention via subliminal presentation. Consistent with the mind's sensitivity to survival threats, subliminally presented threatening stimuli elicit stronger skin conductance, startle eye blink, and more negative downstream evaluative responses relative to the undifferentiated responses to negative, positive, and neutral stimuli. And in total, the present work makes clear that threat superiority is not a byproduct of conscious attention to non-threatening stimuli, and instead arises from the mind's sensitivity to survival threats.